Hello and welcome. In this video we are going to design ring magnet, but this time it will be in 3 dimensions. So I will go here to project and insert Maxwell 3D design. And now let's rename this file as ring magnet 3D, and let's choose the solution type to be transient solution type here. And now let's draw the cylinder with outer diameter of the ring magnet. So I will give it here a radius of d outer divided by 2. The outer diameter of the ring magnet is here about 15 millimeter. So it's about here 15 millimeter, and the height is about 3 millimeter. And here number of segments, I will set it now to 0 and click here apply. We can set fit all here to show all the volume of the cylinder. Now we can take this cylinder number 1 and copy it and paste it here, but in this time we will change this d outer diameter to d inner diameter, and the inner diameter here has unit type of length and in millimeter, and I will change this do to di, and di here is equal to 10 millimeter. Sorry. Okay, this di here is about 10 millimeter, so di divided by 2 equals to 5 millimeter. Now we have two cylinders in 3 dimensions. We will subtract the small cylinder, which is cylinder number 2, from cylinder number 1. So I will select them and go to edit and Boolean and subtract here. Similarly, like we did in 2-dimension design. So now we have this shape of ring magnet. I will assign material here to N35 material, and set the magnetization direction in positive axis of Z axis here, like this. Sorry. And click here OK. Now let's change the color to be red, like we did in previous designs. And now let's add a region around this ring magnet. So we'll go here to draw and select region and set a bed in all directions and give it here about 150. In X, Y, and Z, and click apply. Now we have this region around the magnet, and we can go to define mesh operation. I will select both them like this and right click on them to assign mesh operation. I will choose here surface approximation and set up the resolution like this, and I will add a solution type. So the stop time is 0.1 and the time step here is 0.01. Of course this is a second and this here is a second. and we can see fields here like this, and click OK. Now let's plot the magnetic field density uh, at the surface of the ring magnet. So I will hide this box now and go to the surface of the ring magnet. I will choose here faces, and I will select the upper face and sides of the permanent magnet and the bottom face here like this. Sorry. And right click on them and choose magnetic field density here like this, and click OK. I will also plot a plane. This plane will be exactly in the middle of the ring magnet, so it will be like this. I will give it exercise of 1.5 divided by, or sorry, multiplied by outer diameter of the ring magnet, and y size equal to 1.5 multiplied by outer diameter of ring magnet, and its position will be minus 1.5 multiplied by outer diameter of ring magnet. This will be divided by 2, and same here. And for z axis it will be equal to minus height divided by, or sorry, height divided by 2. Divided by 2. Let's see what happens here. So the plane is exactly in the middle of the ring magnet like this. I will draw also another plane. So let's now give it a color from here. Sorry, let's make this objective and edit properties. Now I will give it a color of white color with full transparent like this, and I will draw another plane but in YZ axis like this. So I will choose here YZ axis and draw another plane like this. I will give it also dimensions in x in y as a y size 1.5 multiplied by outer diameter, and here also 1.5 multiplied by outer diameter. And for y direction this will be minus 1.5 multiplied by outer diameter divided by 2, and for z direction this will be height divided by 2, or sorry, it will be also minus 1.5 multiplied by the outer divided by 2 like this. Let's see what happens. So now this is our plane. I will give it also a color of white color like this, and full transparent like this here. Okay, now let's plot flux lines or flux vector for this two planes here like this. Okay, so now let's check the simulation here we have no problems. We can analyze all data here to see what happens. Well, now this is our design here in 3 dimensions. We can choose moment of 100 millisecond and plot our magnetic field like this. So here we set the magnetization in the positive direction of Z axis. So we can notice that magnetic field flux lines go from north to south pole in both sides of ring magnet like this. I want to just increase the plot size. So I will increase the spacing to more show magnetic field lines. Well, now I will reassign again this B vector only to YZ plane like this. Let's reassign B vector here like this. Okay, we can see here that magnetic field lines go from north to south pole like this on both sides of the ring magnet, and from the hole also for the ring magnet. So 3D design gives us more information and more details about magnetic field distribution for a design like ring magnet. This cannot be seen in 2D design. So that's for ring magnet. This is exploration for ring magnet. So hope to see you in next video. In next video we'll investigate the arc magnet. We'll split this ring magnet into many small magnets, many small arc magnets, and we will explore that. So hope to see you in next video.